Hello, this is Dr. VC Sontake, and I am the course faculty for the course Engineering Thermodynamics. The objectives of this video lecture are to explain thermodynamic equilibrium and necessary condition to exist it, to explain mechanical, thermal and chemical types of equilibrium and their effect on the properties of thermodynamic system. So let us start with the thermodynamic equilibrium. Now, before going into the detail of thermodynamic equilibrium, let us talk about the worldly meaning of equilibrium. In a simple sense, equilibrium implies a state of balance or no conflicts. For example, spiritually, when we say when our heart, mind, body, and soul, all these are in the state of balance, the human being experiences or feels is a great peace because there is no conflict between either of these subconscious body, subconscious objects of the body. So when I say equilibrium, it is a balance, no conflicts, anything which is not contradicting each other in that particular state of equilibrium. So in an equilibrium state, there are no unbalanced potentials or no driving forces within the system, particularly thermodynamic system. So a thermodynamic system will exist in a thermodynamic system when the macroscopic properties of that particular thermodynamic system are not changed if the system switched from its existing state. That is, when it is moved or deviated from its existing state and no change in the macroscopic properties are observed, then system is said to exist in a state of thermodynamic equilibrium. Here, macroscopic properties are the properties which are observable in characteristics. So thermodynamic particularly deals with the study of thermodynamic system or different processes only when they exist in the equilibrium states. Thermodynamic studies properties of those thermodynamic systems that are in equilibrium states only. The moment thermodynamic equilibrium is not existing, thermodynamic studies will not come into picture. For a thermodynamic system to exist in a state of thermodynamic equilibrium, following three types of equilibrium are must be attained: mechanical equilibrium, thermal equilibrium, chemical equilibrium. A thermodynamic system is said to exist in a thermodynamic equilibrium only when these three types of equilibrium conditions are attained or achieved. So let us discuss one by one each one type of equilibrium. So first one is mechanical equilibrium. In mechanical equilibrium, there are no unbalanced forces within the system itself or between the two different systems or between the system and its surrounding. Whether it is the different parts of the same system or two different systems or between system and the surrounding. If both are subjected to similar type of forces or there is no unbalanced force, then they will said to exist in a state of mechanical equilibrium. The pressure in the system is same at all points in the same system or between two different systems or between system and the surrounding, and does not change with respect to time. For example, let us consider a system A and pressure at different parts of this system A is 20 bar. So system A can be called in mechanical equilibrium. Similarly, if system B, its different parts are subjected to the same pressure, let's say 20 bar, it will also be in mechanical equilibrium. If we bring system A and system B together, since pressure values are same in system A and system B, so both will be said to exist in a state of mechanical equilibrium. If system A and system B are then exposed to the surrounding, let's say at 20 bar, so system A, system B and its surroundings, their surrounding will also be in mechanical equilibrium. Now what happens if mechanical equilibrium does not exist? So under such condition, system and surrounding or two different systems will be subjected to different pressures, and there cannot be a single pressure value which can be represented as a system pressure as a whole. There will be different pressure values if mechanical equilibrium condition is not satisfied. Second type of equilibrium is thermal equilibrium. A system is said to exist in a thermal equilibrium if the temperature is the same throughout in the entire system, or throughout two different systems, or between system and its surroundings. So for example, system A, the temperatures of both different parts of the system are same at 20 degrees Celsius. So it is in thermal equilibrium with respect to itself. If system B, its various parts are subjected to same system, let's say 20 degrees Celsius, it is also in thermal equilibrium with respect to itself. If I talk about the system A and system B, they are also in thermal equilibrium. And if both are exposed to the surrounding at 20 degrees Celsius, so system A, system B and surrounding, all the three will be in thermal equilibrium. If thermal equilibrium does not exist, there cannot be a single temperature which can be represented as a system temperature as a whole. So there will be different temperatures to which the system will be subjected to under the condition of thermal non-equilibrium condition. Now last one is chemical equilibrium. Under chemical equilibrium condition, no chemical reaction takes place in the system and the chemical composition does not change and remains same throughout the system. So for example, let's say system A is there and chemical composition or of this system A is everywhere 20% by mass or by volume. So it is in chemical equilibrium. If system B is having the same chemical composition everywhere, let's say 20%, it is also in chemical equilibrium with respect to itself. System A and system B will also be in chemical equilibrium with respect to each other. And if it is exposed to the surrounding at the same chemical composition, all the three entities will be in chemical equilibrium. So, what is the condition for thermodynamic equilibrium to occur? So, this is the necessary condition. If let's say some process is taking place, so for any process or for any thermodynamic system to be in thermodynamic equilibrium, first mechanical equilibrium condition must satisfy, then thermal equilibrium condition, and finally chemical equilibrium condition must satisfy. Only then the process or thermodynamic system will be in thermodynamic equilibrium. So this is the most necessary condition. If either of the equilibrium condition is not satisfied, then system or process cannot exist in thermodynamic equilibrium. So after watching this video, you will be able to explain thermodynamic equilibrium and necessary condition to exist it, and able to explain mechanical, thermal and chemical equilibrium and their effects. With this, I come to an end of this video lecture. Thank you for your kind attention and passionate listening. Happy learning.